Hi everyone, I'd like to use this example to illustrate how to find a linear correlation coefficient as well as how to conduct a hypothesis testing for a linear correlation coefficient. And finally, I'll also show you how to find a linear regression. Alright, so let's take a look at our data. So we have repair causes for car crashes at 6 miles per hour in full front crash test, and the same car crash at 6 miles per hour in full rear crash test. Here we have 7 different type of cars. And first we like to find the linear correlation coefficient between front and rear. And we also like to test if there is sufficient evidence to conclude that there is a linear correlation between the repair costs from full front crashes and full rear crashes. And here we like to use alpha equals 0.05. So first let's find the linear correlation coefficient. So here's the formula. So what I want you guys to do during the test will be filling all these summations as well as the sample size n. And after you do that, then you can use the function in your calculator to get the final answer without plugging in all these calculations in your calculator. First, turn on your calculator, go to Stat, Edit, and then input both of your data. So here L1 is for front, L2 is for rear, and always double check to see if you input your data correctly. Then click on Stat, and go to Calc, choose second variable statistics, and then make sure it's referring to L1 and L2. Usually that's the default, but if not, then you make sure it's doing the calculation for the two columns where you input your data. Alright, so here you can see you have your sum of x squared. Scroll down, you find your n, sum of y squared, and then also your sum of xy. So just plug in all these numbers into your formula. Then for the final answer of your linear correlation coefficient, go to Stat again, now go to Tests, and then select LinReg t-test. Right, so make sure these inputs where refer to your data, where you store your data. And then we'll look at the alternative hypotheses in a minute, but in this case it's actually a two-tailed test. Right, so then go to Calculate, and then scroll down. Here it's your R, which is negative 0.283. Alright, so that's how you find your R. Then let's work on the hypothesis testing. So here are the major 5 steps that I have been mentioning since chapter 8. So for the first step, setting up the hypothesis. So here the claim is there is linear correlation. So which means your linear correlation coefficient shouldn't be 0. Here we use rho not equals 0 as our alternative hypothesis, and that's the claim. So this notation that looks like a P is actually a Greek letter called rho. Right, so then this tells us we have a two-tailed test, and then the null hypothesis will be rho equals 0. Then calculate the test statistic. So here's the formula, and then you can get t equals negative 0.659. So this result is also on your calculator. So from the same output of using the LinReg t-test, you see that test statistic t is up here. So you could just use that, or you can just plug in the calculation, which is not very difficult. So now our test statistic has a t-distribution with degrees of freedom equals n-2, not n-1. I know we've seen n-1 a lot, but that doesn't happen all the time. So in this case, the test statistic has a t-distribution with degrees of freedom equals n-2. So in this case, it's 5. Alright. Then step 3, find the p-value or the critical value. So for the p-value, so again, that's how you find the p-value, which is the probability of t less than negative 0.659. So that's the left tail area. But because this is a two-tailed test, you need to double that area. Or you can just look at the output on your calculator again. see that's your p-value. Okay. Then for the critical value, so it's kind of unique in this case. So we need to look at table A6. I know the test statistic has a t-distribution, but for testing a correlation coefficient, we actually need the Pearson correlation coefficient as our critical values. So on table A6, it's actually pretty straightforward to read. First, which is your alpha? In this case, alpha is 0.05. And then what is your sample size, which is n? So your critical value will be plus or minus 0.754. So you can see there's actually quite a lot of limitation for this table. For example, what if alpha is equal to 0.1? So we don't have that here. So in that case, we cannot use this table. All right, but if I give you any question like this in the test, I'll make sure you can find these alpha on table A6, and I'll of course provide you table A6 as well. All right, so here are the critical values. So we have a plus or a minus. So basically, to the right of the positive critical value and to the left of the negative critical value are the rejection region, and in the middle region will be the area where you do not reject your null hypothesis. All right, so let's take another look here. So step 4, make a decision. So for the p-value method, you just compare your p-value with alpha. So in this case, our p-value is greater than alpha, so we fail to reject the null hypothesis. Now in the test, it's very important that you tell me how you make your decision instead of just giving me your decision like reject the null hypothesis or fail to reject the null hypothesis. So you do need to provide me the reason. And also, don't just say reject or fail to reject. You also need to tell me what are you rejecting and what are you failing to reject. All right. Then for the critical value method, so as I mentioned, so when R is greater than positive 0.754 or when R is less than negative 0.754, then we reject the null hypothesis. But in this case, our R is actually greater than our test statistic R, it's negative 0.283, which is greater than negative 0.754 and also less than positive 0.753. So it's not in the rejection region. So that also tells us to fail to reject the null hypothesis. All right. Then finally, draw a conclusion. So always start with the template. So here our claim is under the alternative hypothesis because it does not contain equality. And then our decision was failed to reject the null hypothesis. So you will start with the template, which is there is not sufficient evidence to support the claim. So start with this template. That then fill in the rest by going back to the original question. So the claim from the original question is there is a linear correlation between the repair cost from the full front crashes and full rear crashes. So here also I put underline for linear because be careful for your conclusion about testing a linear correlation coefficient. Here, although we don't have enough evidence to support the claim that there is a linear correlation between these two variables, but it doesn't mean there is no other type of correlation exists there. This test is only for testing linear correlation. Okay, so that's why it's important that you include the word linear correlation because that's what we're testing. All right, so that's the full process for hypothesis testing, for testing a linear correlation. Now finally, I'd just like to show you how to find a linear regression from the same data set. So here we like to let the repair cost for the full front crashes be the predictor, and that's our x. So y will be the repair cost for the full rear crashes. All right. So the linear regression is like a linear equation. So you have an intercept b0 and also a slope b1. And here we use right hat to represent our dependent variable. All right. So here to find the slope b1, so there are two ways. Basically, there are two formulas in your textbook here. And of course, I'll provide both in the exam as well under the formulas and table link on my stat lab. All right. So here's b1. So again, I'd like you to set up the equations, but then use the output on your calculator to get the final answer. Whichever method you use, you need to show me how you set up your equation. But we can get all these numbers from the functions on our calculator, fairly simple. So let's turn it on again. So first, getting the summation. So you still go to stat, calc, and then the two variable stats, and then enter. Okay, make sure it's referring to L1, L2, or whichever columns you store your data. So here you see you have the n, you have the sum of x, y, sum of x, sum of y, so everything you need. And on the right-hand side formula here, so R is the linear correlation coefficient you calculated earlier. But then for the S of y and S of x, these are the sample standard deviation for y and x respectively. So for y, you see it's here. The S of y equals 972.2. And then the S of x can be found up here. So the 1479.818506. Okay. And then for the final answer of this B1, go to stat, test, and then use the same function as we did to find R, which is the link-reg t-test. Right? And then hit calculate. And then see your slope, which is the B on the output of your calculator. That's the negative 0.1856310.568. Right? So that's how you get the slope B1. Then finally, we need to get the intercept B0. So there's also two formulas for that. And then again, you can find those summation under the stat two variable stat function on your calculator. And then for same as you can find the x bar and y bar under that same function as well. All right, and then for the second formula here, that B1 is the B1 that you just calculated in the previous slide. Okay, so you put everything in, or even simpler, just look at the output of your calculator. So here the B0 is this A here under your calculator after you use the link-reg t-test function. Right, so that's your intercept. So finally, you need to also write out your final answer. So y hat is equal to 2062.616, which is the intercept, minus 0.186. So the negative 0.186, that's your slope, and then multiply by your predictor or your independent variable x. Okay, so that's it.